So today is our lesson number 2, still about angles and triangles, continuation of what we had last time. And if time will permit, we're going to reach up to 6 trigonometric functions, right triangle approach, or at least those things that will be needed here. So let's have a recap of what we had last time. So last time we had trigonometry. We defined it as a branch of mathematics dealing with the study of triangles and the measurements of their parts, sides, and angles. We say that trigonometry is not only applicable to triangles or to situations involving triangles, but also to those phenomena that behave periodically, or that is sinusoidal in nature or repetitive in nature. So there are no triangles in such, but they involve when mathematically modeled trigonometric functions, especially sine and cosine. So trigonometry comes from two Greek words, trigonon, which means triangle, and metron, which means a measure. Let me correct what we had last time. Metron means a measure, not to measure. Metriin is the one that means to measure. Metria, measurement. And also we had angle, and we say that angle is a union of two rays meeting at a common point called its vertex. Then we had kinds of angles according to amount of rotation, or that is about the size of angles. We have acute, right angle, obtuse angle, and then zero angle, straight angle, and reflex angle. Now, as to relationship, we have complementary angles, supplementary angles, conjugate or experimentary angles, and also we define triangle. So we say that a triangle is a polygon formed by three non-collinear points joined in succession by line segments. So that means it is a polygon having three sides. Main parts, we have vertices, sides or edges, and angles. For secondary parts of triangle, we have altitude, median, perpendicular bisector, and angle bisector. We classify triangles according to sides, according to angles, and as to general classifications. According to sides, we have scalene, isosceles, equilateral. So relative to angles, we have acute triangle with a special case of equiangular triangle that is having all the angles equal. And then we have a right triangle with important parts, hypotenuse, and the two legs. The angles are 90 degrees and two acute angles. So the hypotenuse is the longest side facing the 90-degree angle. The acute angles theta and beta, which are denoted here, the sum is 90 degrees, meaning they are complementary angles. Then we have obtuse triangle. Now, as to general classification, there are only two triangles, either right or oblique. So again, when you say right, it has a 90-degree angle. And if it has no 90-degree angle, it means oblique triangle. So that is, oblique triangle is either an acute triangle or an obtuse triangle. So let us have some relationships of sides and angles in a triangle. First, we begin with angle-side relationships in a triangle. Side angle relationship. So for side angle relationship, given a triangle ABC, so let's say AB and BC are the sides of two of the sides of a triangle ABC. So if AB is greater than BC, then the angle opposite to the side AB is larger than the angle opposite to the side BC. So in general, so mm, the longer the side, the larger the angle opposite to it. Angle side relationship. For triangle ABC, if the measure of angle A is greater than the measure of angle B, then the side opposite to it, to angle A, is longer than the side opposite to angle B. So in general, the the larger the angle, the longer the side opposite to it. Triangle inequality. What does it mean? Given a triangle ABC, if AB, BC, and AC are sides of the triangle ABC, then AB plus BC is greater than AC. So in general, take two sides of a triangle, take the sum, always greater than the third side. Angle sum. In a triangle ABC, A, B, and C are angles, which are interior angles. The sum is 180 degrees. So let us have some examples. Solve the following problems. The complement of angle A is 6 degrees is smaller than twice angle A. Find the measure of angle A. So angle A is our focus. Let X the measure of angle A. What is its complement? 90 degrees minus X. Okay? So if X is the angle A, its complement is 90 degrees minus X, or 90 degrees minus A if you use the A. So what is our working equation? The problem says the complement of angle A, that is 90 degrees minus X, is 6 degrees smaller than twice angle A. So twice angle A, meaning 2x minus 6 degrees. So that is 90 degrees minus X. Solving this equation, transpose 2x on the left side, getting negative 2x plus negative x, negative 3x. On the right side, negative 6. 90 when transpose is negative 90 plus negative 6, negative 96. Let's divide both sides by negative 3. So we get x equals 32 degrees. So we are asked of the measure of angle A. So angle A is 32 degrees. We are not asked of the complement. But if you're asked of the complement, it is 58 degrees. So let us have the second one. An angle is equal to 3 times its supplement. What are the measures of the two angles? So we have x to represent the unknown angle. Now, what about its supplement? The supplement of that unknown angle, which is represented by x, is 180 minus x, 180 degrees minus x. That's the supplement of angle that is unknown, angle x. So what is said about angle, the angle x? It is 3 times its supplement. So 3 times 180 degrees minus x. So let's distribute 3, getting 540 degrees minus 3x. So transpose negative 3x on the left, getting 4x now when added to x, because negative 3x when transposed becomes positive 3x plus x 4x. On the right side is still 540 degrees. Let's divide both sides by 4 to get 135 degrees. So that's the measure of the unknown angle. What about the supplement? Because we are asked of the measures of the two angles. So the supplement, 45 degrees. So therefore, the angles are 135 degrees and 45 degrees. They are supplementary angles. Let's have number 3. You just pick up in case you have questions. Huh? This is just a review of your geometry. Actually, this is not really trigonometry. The supplement of an angle A of an unknown angle is 44 degrees. It's smaller than thrice its complement. So it's like a combination of geometry and algebra word problem, no? But it's about principle in geometry. So again, the supplement of an angle. So we have an unknown angle. So, and its supplement is 44 degrees smaller than thrice its complement. So an angle has a supplement, has also a complement, and the supplement is compared to the complement. What is the angle? We are not asked of the supplement, we are not asked of the complement, we are asked of the angle. So, but we need the supplement and the complement to find this angle. So let x be the measure of the angle that is an unknown. Then supplement is 180 degrees minus x. So that's the supplement of the angle. 90 degrees minus x is the complement of the angle. So what is the relationship between this supplement and complement? So it is said that the supplement is 3 times the complement minus 44 degrees, because 44 degrees is smaller than twice the complement. So let's work on this equation. Simplifying the right side, distribute 3 inside this terms inside this parenthesis. We have 270 degrees minus 3x. So then minus 44 degrees. Negative 3x when transposed and then added to negative x, we now have 2x. 270 degrees minus 44 degrees, then minus 180 degrees when 180 is transposed, negative 180 degrees, to getting 46 degrees. So dividing by 2, both sides we get x equals 23 degrees. So that's the angle. We're asked of the angle only, not the complement, not the supplement. So that's the 23. But if you're asked of the supplement, of course, that is 157 degrees. And then the complement is that right? 57, 157. Guys, the supplement. Guys, do not chat. I can't see your chat.
Yes daw po.
You
Yes
just
po.
speak. What about the complement if asked? 67?
Yes po.
That's
Yes po.
okay. Let's have another topic. So actually, this is just to expand or to expound degrees, no? The concept of degrees, degree measure, because we used that already in the in problem solving. How do we define degree measure? The angle formed by rotating the initial side exactly once in the counterclockwise direction until it coincides with itself is said to measure 360 degrees. And that is equal to 1 revolution. To illustrate, so we have this angle. So we rotate it 1 complete rotation. So that is 1 revolution. And that is equal to 360 degrees. And 1 over 360th part of a revolution is 1 degree. So that is how we define a degree. So 1 degree is equal to 1 over 360th part of a revolution, or 1 complete rotation, 1 over 360. A degree is divided or is composed of 60 minutes. No, a degree is divided into minutes, 60 minutes. So, and 1 minute is divided into 60 seconds. So let's have the following examples. Convert to degrees. 2.5 revolution, so or 2.5, 1 complete revolution, 1 complete rotation. So that is equal to 2.5 revolution is equal to 2.5 multiplied by 3 over 360 degrees per revolution. So 360 degrees, there is 1 revolution. So this is our conversion factor. So 2.5 times 360 is 900 degrees. So revolution is cancelled. So 2.5 revolution is equal to 900 degrees. What about 40 degrees, 25 minutes? So no problem on anymore with the 40 degrees. Our problem is the 25 minutes. How to convert 25 minutes to degree measure. So 40 degrees, 25 minutes means 40 degrees plus 25 minutes. But 25 minutes when multiplied by 1 degree per 60 minutes, this is our conversion factor. 1 degree is equal to 60 minutes. So that it will not affect the value. It will only change the form, no? So it is actually equivalent to 1. So 1 degree times 25 minutes over 60 minutes. So that is equal to around 0.42 degrees. So 40 degrees 25 minutes is equal to 40.42 degrees. Actually, you can convert it directly to your calculator. But this is how to do it manually. 125 degrees, 42 minutes, 30 seconds. So let's take the 30 minutes, convert it to minute. 30 seconds, convert it to minute. So to minutes measure. So 30 minutes, 30 seconds times 1 minute per 60 seconds. So seconds cancel. So we now have 30 divided by 60 times 1 minute. So that is 0.5 minutes. Then add this to 42 minutes. So we have 42.5 minutes. So we have to convert 42.5 minutes to degrees, to degree measure. So we now have 42.5 minutes. So that is multiplied by 1 degree per 60 minutes. So that is equal to 0.71, around 0.71. So hence, we have 125 degrees, 42 minutes, 30 seconds is equal to 125.71 degrees, approximate of course. No? Convert to degrees minutes to MD, to DM. So 100.26 degrees. So let's take the decimal part of this degree measure. So 0.26 degree times 60 minutes per 1 degree. And that is equal to 15.6 minutes, approximately 16 minutes. So 100 degrees, 16 minutes is equal to this 100 degrees, 100.26 degrees. So again, in terms of degrees minutes, 100 degrees, 16 minutes approximately. What about 28 degrees, 28.55 degrees? So let's take the decimal part, 0.55 degree, that is times 60 minutes per degree. So getting 33 seconds. 33 minutes, sorry. So 28 degrees, 33 minutes, that is the equivalent for 28.55 degrees. Convert to DMS, so degrees, minutes, seconds. 44.37 degrees. So 0.37, the decimal part, let's take that, times 60 minutes per degree. So that is 22.2 minutes. So let's convert 0.2 minute to seconds, the decimal part of the minute. So that is times 60 seconds per minute, getting 12 seconds. So hence, we have 44 degrees, 22 minutes, 12 seconds. So that is 44.37 degrees. Any question, guys? So this is just a review. So I think you know things like this. So there is question last year about conversion. So at least you should know. 0.86. So the decimal part is 0.86 degree times 60 minutes per degree. So that is 51.6 minutes. So let's take the decimal part of that minute, the minute measure. So that 0.6 multiplied by 60 seconds per minute, so getting 36 seconds. Hence, we have 325 degrees, 51 minutes, 36 seconds. Radian measure. So we're done with the degree measure. What about radian measure? How do we define radian measure? So to define radian measure, we need the following terms: central angle. So when we say central angle, this is an angle whose vertex is at the center of a circle. And the sides or the sides are formed by the radial lines or segments. The rays of a central angle subtend or intersect an arc on the circle. So let's illustrate. So this is the angle. So this is the circle of radius, let's say r. So this is the measure of the angle, this R1, the arrow going in counterclockwise. So the central angle subtend an arc. So this is the arc subtended by this central angle. Okay. So this central angle and this is the subtended arc. So that is how central angle is related with this arc. One radian is defined as a measure of a central angle of a circle when the radius and the subtended arc of the central angle are equal. So let's have this. Let's say we have a circle. The center of this is the vertex of this angle. This is the measure of the angle. Now this is equal to 1 radian if this radius becomes equal in length with this arc. If I'm going to stretch this arc and let's say this becomes equal to r, so this is now 1 radian. So that is how we define 1 radian. Again, 1 radian is a measure of the central angle when the radius and the subtended angle, when the radius and the subtended arc of the central angle become equal in length. So this arc has a length equal to the r of this circle, then this central angle now is equal to 1 radian. And that 1 radian is actually equal to 180 degrees over pi. So that is around 57.296 degrees. So in 3 decimal places. Now we are going to talk about arc length. So that is the relationship between S, R, and theta. Arc length, R, and theta, this arc. So in general, how long, how to compute the arc length. So that is dependent on the radius of the circle and the central angle. So let's say we have this circle and containing in this circle are the two sectors. We call this sector. Okay. So that it's like a pizza, circular pizza. One slice is a sector. Now these two sectors, of course, are bounded by radial lines, no, or radius segments. Now, the central angle in the blue is theta. The length of the arc subtended by this theta is S. In the yellow sector, the arc is S sub 1, the subtended arc by the central angle theta 1, theta sub 1. So S sub 1, theta sub 1. From geometry, the central angle is proportional to directly proportional to the length of an arc. So theta over theta 1 is equal to S sub 1, S over S sub 1. If theta 1 is equal to 1 radian, if this is 1 radian, this theta 1, so R, the radius becomes equal to S sub 1. That is from the definition of 1 radian. If theta subtended, if the central angle happens to be 1 radian, so it means S sub 1 is equal where? Is equal to what? To this radius. So hence, from this formula, theta over 1 now, because theta 1 is 1, S over R. So hence, we have S is equal to R theta. S is the arc length. So for a circle of radius R, a central angle of theta radian subtends an arc whose length is given by R theta. So let us have the following examples. Find the length of the arc of a circle of radius 2 feet subtended by a central angle of 0.25 radian. So we're given r equals 2 feet, theta 0.25 radian. We're asked of the arc length or S. So that is the subtended arc, no? Yan. By the central angle. So how to find S? That is equal to r theta. So what is r? 2. And then what is theta? 0.25. You omit the region if you are computing S. Do not include the region anymore. So we're going to take the numerical number only. So the unit for S is in terms of feet also. So S is 0.5 foot. Okay, so that is the length of the arc. What about the second problem? Usano is swinging on a rope tied to a tree branch, going back and forth alternately over land and water. If the rope from where it is tied to the bottom of shoes of Usano is 2 meters, how far does the bottom of his shoes travel in one swing if the rope swings through an angle of 5 pi over 12 radians? So solutions. Well, we have a tree, and this is the branch of the tree where the rope is tied. So let's say initially it's here. The length from this point to the bottom of the shoe, or yan. So we have now our shoes 2 meters, no? So that's the length of the rope plus going to the bottom of the shoe. So the rope swings up to an angle of 75 degrees. Yan. So how far does the shoe or the shoes travel, no, from this point to this point? So meaning that's the length of the arc. Okay, it forms actually part of a circle. So how long is this when it's stretched? So this is the land, this is the water. So we are required to get the S. So what is S? R theta. So 2 times, so what is the angle? 5 pi over 12. We don't include the unit anymore. So just the feet. So I mean meter. So this is 5 pi over 6 meters, or approximately 2.62 meters. Radian degree relationship. 1 revolution is equal to 360 degrees. Now, the circumference of a circle of radius r is given by 2 pi r. How to get the equivalent of 360 in terms of radian? So we use this formula. S equals r theta. But what is S? 2 pi r. So that is the length of the circumference. And that is equal to r theta. R is cancelled. So if theta is 360 degrees, then it is equal to 2 pi radians. Okay? So 360 degrees is 2 pi radians. Divide by 2, pi radians is equal to 180 degrees. Radian measure can be omitted, so you can just write if you want pi. So pi is equal to 180 degrees. 1 degree is equal to pi over 180 radians, or simply pi over 180. So this is the conversion factor. So if you want to convert degrees to radian measure, so this is what your multiplier is. So if you want to convert your angle in terms of degree measure, you multiply the radian measure by 180 degrees over pi. This is the conversion factor from radian to degree measure. So let us have the following example. Convert to radian measures. 135 degrees. So that is multiplied by pi over 180 degrees. So getting, using your calculator, 3 pi over 4, or 3 pi over 4 radians. 90 degrees. How to convert? Multiply by the conversion factor, pi over 180 degrees. So it is equal to pi over 2, or pi over 2 radians. What about conversion to degrees? From radian to degree measure. So 3 pi over 7 radians. So that is equal to 540 degrees over 7. and that is approximately 77.44 degrees. Okay, so we multiply by 180 degrees over pi region. Region is cancelled. So 3 pi over 7 times 180, 540 over 7. What about 4 pi over 3 regions? So 4 pi over 3 times 180 degrees over pi, pi is cancelled. So 4 times 180 over 3, that is 240 degrees. So you should be familiar with the following angles. 30 degrees, that is pi over 6, 45 degrees, pi over 4, 60 degrees, pi over 3, 90 degrees, pi over 2, 180 degrees, pi, that is pi, 360 degrees, 2 pi. A question, guys? Of course, no question. Area of a sector. Now, how to get the surface area of, let's say, a pizza, a slice of a pizza. So this is the formula to get the approximate area, for instance, of a slice of pizza in surface area, where theta is in radians. So we have 1/2 r squared theta. So it is dependent on the radius and the central angle in radian measure. Associated with a central angle in a circle is what we call speed and linear speed. I mean, angular and linear. So how fast does the angle change, no, relative to time? So that is angular speed. So how fast does a point on the circle moves along the circumference relative to time? That is linear speed. Or if the circle is rolling, how far does a point on the circle travel in a linear motion? So let's say you have a point on the circle. So the circle will roll on a level surface. How far does the point travels, no? Okay. So along the straight path or linear motion. Omega, angular speed, theta, central angle, t time, s, arc length. Omega and linear speed, meaning this v and omega related by this equation. V is equal to r times omega, meaning linear speed is directly proportional to omega, where r is direct proportionality constant. So we can also say that linear speed 1 over linear speed 2 is equal to linear speed 1, angular speed 1 over angular speed 2. Let's say I have a circle here. So this is how to illustrate. I have a point. Now, if this circle will rotate in its position, so this point A will travel to, let's say, at point B. Now, if this is going to roll, so reaching point B, so the A now will go here. That is equal to this line segment AB on the level blue. No? So this segment AB on the level ground or level surface is equal to this arc AB. Once this rolls, it will reach this point, for instance, point B. So it means the point travels along the circle an arc of length AB. So they are just the same. So let us have a particular problem. A 24-inch pizza having a diameter of 24 inches, no? To be divided into 8 equal slices, forming eight sectors, of course. Find the surface area of one slice of a pizza. Of course, approximate only. So R is 24 inches divided by 2 because the diameter is 24. So radius is 12 inches. Theta in radian measure is pi over 4. That is 360 degrees over 8 because we are going to divide by 8. So central angle, therefore, is pi over 4 or 45 degrees. That is the angle of one sector. After all, they are equal to each other. You can take just one of them. Area is equal to 1/2 r squared theta. So plug in values, 1/2 times 12 squared times pi over 4. That is 18 pi square inches. That's the area of one slice of pizza approximately. You can have it in decimal if you want. to 2 decimal places. A question, guys? No question? Okay. A child is spinning a rock, so don't chat on the box because I don't see your chat there. A child is spinning a rock at the end of a 2-foot rope at the rate of 80 revolutions per minute. Revolutions per minute means RPM. Again, a 2-foot rope rotates at a rate of 180 revolutions per minute. So imagine you have a rope, tied in a rope. At the end of the rope is what? A rock, and you spin it. It will form a circular path. No? So especially if you rotate it fast. How fast? 180 degrees, 80 revolutions per minute. So that is 180 complete rotations. So meaning 180, 360 degrees. 180 of 360 degrees. Find the linear speed of the rock. How fast the rock travels along the circular path. So given the amount of change, the changes in the change in the angle, 180 relative to time, 180 revolutions per minute. What is the linear speed of the rock in feet per second, per minute? No? Because we're given unit in feet. So we have this. So we have this imaginary path. This the rock, the black one. 2 feet, the radius. So the angular speed is 180 RPM, 180 revolutions per minute. So yung mga motor, meron yung motor umiikot din RPM. Normally ang measurement ng rotation RPM. So we want V, that is in feet per minute. So we convert the formula is for radian, no? Radian measure. So we convert 180 RPM in terms of radian measure. So that is 2 pi for every 1 revolution. 1 complete revolution, 360 degrees. So 2 pi. So 2 pi per 1 revolution, cancel revolution. So we have 360 pi radians per minute. Now, when substituted, we remove the radian. We don't need that. So 2 feet times 360 pi per minute. So that is 720 pi feet per minute, or 2,261.95 feet per minute. That is how fast the rock is traveling around the path, no, circular path. For every minute, it has traveled, kung i-stretch nyo, gagawin yung straight, 2,261.95 feet per minute ang kanyang speed, no? Linear speed. Kaya kung makaka 2 minutes siyang nag-ikot, kung inikot niya ng 2 minutes, makaka 4,000 plus the distance travel. Kung naman ano lang, half minute, so half of this. Okay? So what about this one? A question, guys? My dog is, I think, hungry now. Are you hungry now, Usano? My dog is here. 2 pulleys. You know pulleys? So these are simple machines. One of the simple machines, pulley. Okay? So it helps what? Speeding, let's say, speeding up a bicycle. No? So remember, in a bicycle, you have a small one in the middle of the back wheel, and then at the pedal there is another one, circular thing there, so bigger than the one that is at the back wheel. So, and connected by normally chain or belt. So in this case, this is connected by belt. So with the assumption that the belt will not slit around the circular thing or the pulleys. So the distance that the belt will travel, that is also the same distance any point on its circle travel. No? Now, if you have a point on the smaller circle and you have another point on the bigger circle, since they move at the same time, so whatever distance traveled by a point on the smaller circle, that is the same distance traveled of a point in the bigger circle. So meaning the arc length in the smaller circle made by a point on that smaller circle is equal to the arc length of the point made by the what? By the point on the bigger circle. So S1 is equal to S2. If S1 is for the bigger circle, then S2 for the smaller circle, they are equal if they move at the same time. They move at the same time again with the assumption that the belt will not slip around the circle. So although there are chances of course na mag-slip yon, no? A little, kaya mayroong a little error. But with that assumption, so S1 is equal to S2. We need to know the angle that the smaller pulley turns, no? So at what angle does the smaller pulley turn? So the smaller pulley turns at theta 2, and that is not equal to theta 1. Theta 1, once it moves a little, so bigger movement in the angle for for pulley 2, meaning for the smaller pulley. So again, let's say nag-move ng half the half pi degrees to pi radians so more than very more than that for the smaller circle. Okay, so let's see kung nag-turn siya ng 1 revolution 360 degrees, ilan ang movement ng angle ng smaller. So again, S1 is equal to R1 theta 1. So let's solve for S1 of the bigger pulley. So that is 15 because the radius is 15. Diameter is 30, no? 15 radius for the smaller one, 10. So 15 times 2 pi, so R theta. That is 35 centimeters. So S1, at the point on the bigger circle or pulley, travels 35 centimeters. That is the same distance traveled by the point on the smaller pulley. So 35 centimeters also. We know already S2, so we can now compute theta 2 because we know R2. R2 is 10 centimeters. So 35, R2 is 10, theta 2. So theta 2 therefore is 3 pi radians, or that is 1.5 revolution. In terms of degrees, 540 degrees. A question? You know how to convert 3 pi, ha? 3 pi radians we multiply by 1 revolution per 2 pi. So you will able to get 1.5 revolution. So kapag nag-move pala ng 1 revolution ang bigger circle, nag-move ng ang angle ng nagro-rotate ang pulley, smaller pulley by how much angle? 1.5 revolutions. A question, guys? Still alive, guys?
Medyo po.
Guys? Okay. So let's now talk about right triangles. We will be talking much about right triangles. That is actually the heart of trigonometry, about right triangles and other triangles. Yes.
Sorry po, pero pwede bagalan niyo po konti. I'm so sorry.
It's all right because you can repeat this. The problem that there is no problem in fast. So we were asked that we can deliver it fast because this can be watched again.
Okay. Thank you.
Unlike in classroom setting. Because in classroom setting, we cannot repeat the lecture. So you really have to understand well before finishing the period. Unlike in online, because this is recorded, you can watch anytime, anywhere, and many times, no? Depending on how many times you want. So you can repeat this. You can go over with the part that you miss or you think you feel more focused. Is that clear, guys? Because we have limited time, like you remember in your Gen Math, so it's really hard. So in Gen Math, you had lecture also, I think, in asynchronous schedule. But in our case, very seldom tayo mag-asynchronous. Ang asynchronous nyo, free time. Ano nyo yan? Pwede kayong manood ng kung ano-anong tawag dito, mag-relax. Unless meron na kayong activity na posted. That's the only time you will be using your asynchronous. Or I will be uploading, then you can watch during the asynchronous if you want. But actually, that is formally, but you can actually watch or read the lectures anytime you want also. Ang asynchronous natin, hindi tayo mag-lecture. Ano lang yan, supposed to be kung face-to-face, yan ay pag mayroong blended learning case only na mayroong activity, pero sa bahay pa rin normally ginagawa. Sa Canvas, sa bahay. Okay? Is that all right now, guys?
Okay po, sir.
What time is it now?
It's 3:25.
3:25 po.
So actually, yung first recording, you can watch that in your, the link is given in the
Nice one, Cheyenne.
hello. I ran out of battery. Okay now? I forgot to plug the cord. Because my dog is roaming around, is stepping on the cord. That's why I'm removing the cord. Did you see my dog already?
Di pa po, sir. Pero nasa...
It is in YouTube. You can
Yes
see him,
po.
my golden retriever. But in YouTube, there I had also the Siberian, but unfortunately the Siberian died already. But the golden retriever is still alive, and I have a new one, Saint Bernard. Saint Bernard is outside. We can't get him inside because he's very big. And once he plays with my golden, our things here in the house will be damaged. No? It's very big, perhaps bigger than you, some of you, especially for the girls, no? Heavier than the girls. Okay. Do you see I think the screen disappeared now?
Opo,
Yes
sir.
po. We can't see anything.
Yan. What about that? Do you see now?
Yes po.
Okay. So again, we're talking about triangles, right triangles. In right triangle, we have hypotenuse, legs. The hypotenuse is what? The longest side facing the 90-degree angle. And the legs are the perpendicular sides. The two remaining angles, the acute angles, are complementary. The sum is 90 degrees. Now, there is a theorem, very important, associated in a right triangle. Now, so this theorem is called, what's the name, children?
Pythagorean Theorem.
Yeah, so that's a Pythagorean theorem. You're searching what the pronunciation of Pythagorean. You know, in our American students,
Pythagorean.
Pythagorean, they pronounce it Pythagorean, not Pythagorean. Check it in dictionary.com. What's the pronunciation? Let me check. So let me see. Screen sharing has stopped. Oh, why is it stopped? So let me check. Let me see. Dictionary.com. And I will type Pythagorean.
Sir, it's
Pythagorean. Pythagorean po,
Pythagorean.
sir. Pythagorean.
Pythago. Because we had student, American student, when asked to read, they read it or they say it Pythagorean. So, but of course, the way they speak it is a little bit slang, more slang than us, of course. No? Pythagorean. But see, it's not Pythagorean. So even our foreign students, American students, they pronounce it Pythagorean. Okay now? Or since we're Filipino, you can read it Pythagorean. We won't dive in the pronunciation. What is important, you will be able to answer. Okay? Naka-share ba ang screen, guys? Hindi.
Nakashare po.
Share po.
Shared pa po.
So, Pythagorean theorem is a right. So what does it state? Pythagorean theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides or legs. No? So that is the square of the hypotenuse is equal to leg 1 squared plus leg 2 squared. Now, since hypotenuse, leg 1 and leg 2 are dimensions or sides of triangle, right triangle, they are all positive. So we take the positive square root, it is all for hypotenuse, leg 1 and leg 2. For hypotenuse, sum inside. For leg 1 and leg 2 difference, starting with the square of the hypotenuse, followed by the square of the leg. So again, positive square root. Okay? Now, associated in a Pythagorean theorem is a Pythagorean triple. What is a Pythagorean triple? A Pythagorean triple is a triple of numbers A, B, C, where A, B are the legs and C the hypotenuse, and they are all positive integers or natural numbers. So they satisfy the Pythagorean theorem. So the following formulas can be used to find a Pythagorean triple. Let n and m be positive integers. Again, what are m and n, children? What are n and m? Positive integers or natural numbers with additional conditions later. So we now have, let's say I have n, guys. I have n. So this is my leg, no? With the condition that n is a positive odd greater than 2. So what is an example of value of n, which is one of the legs? Guys, who's the president? If you want, you can call a name.
Si Zenon po.
Okay. What is n? Give me a possible value of n, satisfying the condition. Again, the first condition, n and m are positive integers with an additional condition here. N is a positive odd greater than 2. Give me an example of value of n.
7 po.
7. If n is 7, one of the legs, what is the other leg? 49 minus 1, 48 divided by 2, 20, 24. What about the hypotenuse?
25.
25. Now, if you use the second set of formulas, if you use the second row, so another formula to find, but this time, the condition here is that n is even, that is greater than or equal to 4. Okay? So if n is, let's say 4, so what is the other leg? What is the other leg? President, what's the other leg?
3 po.
3. What about the hypotenuse?
5.
5. So if you want to find a Pythagorean triple, you can use any of these formulas. Just look at the appropriate conditions. So especially the third row. Third row, and here is not the leg, but 2n. But your n is greater than or equal to 2. For instance, if n is 2, 2 times 2, 4, which is when you plug in 4 here, in the first one, you will get a leg 4. Here, to get a leg 4, you need n equals 2. 2 times 2, 4, that is the leg 4. So, but what is n2? That is 4 minus 1, so we'll get 3. So, we'll get the same set of Pythagorean triple. No? Now, a more complicated formula is the last row. M and N are relatively prime. So, meaning they don't have common factor anymore except 1. So, and they are both, again, positive integers. Exactly one of M and N even. So meaning M and N have different parity. If M is odd, N is even. If M is even, N is odd. So that's the condition. And M is always greater than N. Mr. President, you can answer or you can call a name. Give me an example. Ito may example na pala rito. 7 ang M, ang N ay 4. So possible yan. They have different parity. Add even. Dapat even add or add even. But be sure M is greater than what? Than N. Okay? And then they don't have common what? Common factor. Greatest common factor. If M and N are 7 and 4 respectively, so we have 2 times 7 times 4. So that is a big number. 28 times 2, 56. So 56, one of the legs. So the other leg is 56 squared minus 16. That is 49 minus 16. 33. And then the hypotenuse, 49 plus 16, 65. Okay? So to form a Pythagorean triple, so we can use any of this set of formulas. Form a Pythagorean relation for the given right triangle. Let's say I have this triangle with the following sides ABC with C hypotenuse. So what is the relation that I can form out of this? So we have C squared equals A squared plus B squared. What about in number 2? What is the hypotenuse? R plus 1. Legs, M squared and N over R. So what relation can I get out of these sides? R plus 1 quantity squared, because that is the hypotenuse, is equal to R plus 1 quantity squared. R plus 1 is the hypotenuse, is equal to M squared quantity squared plus N over R quantity squared. Or the right side, M to the 4th plus N squared over R squared. So this is the relation that I can get out of this right triangle. What relation? Pythagorean relation. Solve for the unknown side of the given right triangle. Unknown side. Okay? So, actually unknown side, I changed it to solve for the unknown, not for the unknown side. Let me check. Change this. Solve for the unknown given right triangle. For the given right triangle. Okay, solve for the unknown for the given right triangle. So for the given so the first triangle, you have the following parts: 4 inches, 3 inches, they are legs. C, hypotenuse. So we want to know the value of C, the unknown. The unknown here is C. So how to get C? Since it's hypotenuse, it is equal to square root of, applying Pythagorean theorem, square of one leg plus square of another leg, take the square root. So square root of 25, so 5 inches, that's the value of C. What is the unknown in number 2? The unknown is what? X. So solve for X. So the side is x minus 2, but the unknown is x. So x minus 2 is one of the legs. So is square root of, so inside is difference. Hypotenuse is squared minus one leg is squared. So getting the other leg, which is square root of 49, 7. So the other leg is 7. But what is x? 9 centimeters. Okay? So x is equal to 7 plus 2. What about in the third? What is the unknown in the third, guys? The hypotenuse. So again, since this is hypotenuse, inside is sum. So square of the first leg, then square of the second leg. Take the sum, take the square root. So that is 10. So what is z? 5 feet. That is 10 minus 5. A question, guys. So let's move to letter C. Solve the following problems. The perimeter of a right triangle is 40 centimeters. If the hypotenuse is 2 centimeters longer than one of the legs, what are the measures of the three sides? Again, the perimeter of a right triangle is 40 centimeters. If the hypotenuse is 2 centimeters longer than one of the legs, what are the measures of the three sides? So solution, let x be the length of one of the legs. So let's say this is one of the legs, that is x. So the hypotenuse is 2 centimeters longer than one of the legs. So this x, so x plus 2. So that is the hypotenuse. So then we now have the perimeter is 40, and that is equal to the sum of all the sides. The first side is x, the second side, which is the hypotenuse, x plus 2, plus leg 2. What is leg 2 in terms of x? So solving for leg 2, that is 38 minus 2x. Now these measures of the sides of this right triangle must satisfy the Pythagorean Theorem so that we will be able to solve for the x. So x plus 2, which is the hypotenuse, square it. It is equal to the square of one leg, then plus the square of the other leg. 38 minus 2x is the other leg, square it. So let's expand the left and then this second term on the right. So when expanded, we have x squared plus 4x plus 4. Then equals x squared. Then plus 1444. Square of 38 is 1,444. Then the middle term, we have to square what? We have to multiply the first and the second, then double. So when you double, we get what? 152x. That is negative because the middle term is negative. The second term is negative. So plus 4x squared. Let's simplify. X squared is cancelled. So transpose everything on the right, 4x squared. Then negative 152x minus 4x, that is negative 156. 1444 minus 4, that is 1440, equals 0. Divide by 4, we get x squared minus 39x plus 360 equals 0. Now, if you can't do it, if you can't do the factoring, you can use quadratic formula because it's not easy to think of numbers na ang product ay 360 at ang sum negative 39. So, but in this case, the factors are 15 and 24, both negative. So that is 360. Negative 15x plus negative 24x, that is negative 39. So these are the factors of x squared minus 39x plus 360. That is equal to 0. Equate each factor to 0. We have x equals 15 or x equals 24. Which of these two values are accepted? Are they both accepted or just one of them or none of them? Let's see. If x is 15, the leg 2 is equal to 38 minus 2x. But what is x 15? So we get 8. Possible, no? To get to that, to have that leg, value of the leg. What about if x equals 24? Leg 2 is equal to 38 minus 2x. That is leg 2 in the previous discussion or in the previous slide that we had. 38 minus 2 times 24 is negative 10. Is it possible value of the leg? No. So therefore, we don't accept 24 as the value of x. Hence, the possible x value is 15. Therefore, the measures of the sides are leg 1, 15 centimeters, leg 2, 8 centimeters, hypotenuse 17 centimeters. Look at the hypotenuse, 2 centimeters longer than leg 1. The hypotenuse, let's look at the problem again. The hypotenuse is 2 centimeters longer than one of the legs. So in this case, 2 leg 1. No? Okay, let's have the second one. One leg of a right triangle is 6 inches shorter than 6 times the length of the other leg. Yan. If the perimeter is 132 inches, how long is the hypotenuse? We are asked of the hypotenuse only. How long is the hypotenuse? Let x be the length of one leg. So then hypotenuse is equal to perimeter minus the sum of the two legs. No? 132 minus x. So we get minus of the sum. X and 6x minus 6. Why 6x minus 6? Because the other leg is 6 times 6 inches shorter than the length of the other leg. So if x is one leg, so 6x minus 6. So square it. So expanding, we get these numbers on the left. On the right, we have this. Kindly check. You can use calculator if you want. So simplifying, we get 12x squared minus 1,860x plus 19,008 and equal to 0. Divide by 12, we get x squared minus 55x plus 1584 equal to 0. Solving for x, so we equate with this left side, we try to factor. That is x minus 11, x minus 44. X minus 144, I mean. So 11 times 144, that is 1584. So negative 11 plus negative 144, x, both x, so we have negative 155x. So x is 11, x equals 144. Are they both accepted? Let's see. If x is 11, hypotenuse is 61. That is 138 minus 7x. So 61. Okay, possible. No? If x is 144, then hypotenuse is negative 870, which is rejected, no? We don't need this value. Therefore, the hypotenuse is 61 inches long. A question, guys. Mr. President, are there questions from your classmates?
So far po, wala pa pong nag-chat.
Huh?
So far, wala
No
pa.
question? Okay, letter D. If we don't have question, let's proceed. We are just reviewing geometry, huh? Trigonometry. We are not yet in actual trigonometry. Complete the table to form a Pythagorean triple with AB as legs and C hypotenuse. Ito yung aking mga given, 7, 8, 12, 9, 20. You can use any of the formulas listed before to find. I use this. If A is given, I use this formula to find B and C. If A is even, I use this formula. So, and I came up with these values. So these are Pythagorean triples. 7, 24, 25, 8, 15, 17, 12, 35, 37, 9, 40, 41, 20, 99, 100. If you're going to square it, then take the sum. It is the square of the C. You can verify that. Okay? A question, guys? Huh? No more question, guys? Okay, guys.
None po,
None
sir.
po.
Okay, so no more question. So let's now continue with the discussion. So we're done with Pythagorean triple. So we're now ready to begin discussing trigonometric functions. Now, trigonometric functions are very important in trigonometry. Actually, that's why we are going to study trigonometry, to come up with these trigonometric functions. Okay? So, what are trigonometric functions? How do we define them? To define 6 trigonometric functions, children of the Philippines, there are 3 ways. May mga book 1 lang ang dinidiscuss. Meron naman 2. And there are books 3. In our case, we're going to discuss 3 ways of defining trigonometric functions. So, again, there are 3 ways or approaches in defining trigonometric functions. So, we have 3 approaches. Three approaches in defining 6 trigonometric functions. Defining the 6 trigonometric functions. The 6 trigonometric functions. The first one, we have right triangle approach. Right triangle approach. Sometimes in books, you will see right triangle trigonometry. So meaning, the discussion of that trigonometry, right triangle approach. Right triangle approach. So this is the first approach. Right triangle approach makes use of a right triangle for in defining the 6 trigonometric functions. So it uses a right triangle, actual right triangle. A right triangle in defining 6 trigonometric functions, in defining the 6 trig functions, trigonometric functions. But the problem here, limited only to positive acute angle. Ang problem sa right triangle approach that you can define 6 trigonometric functions of positive acute angle only. Yan. Of positive acute angle. So I'm going to enclose this. So just to emphasize the limitation of this right triangle approach. Limited to positive acute angle only. Positive acute angle only. So meaning, we cannot define sine, cosine, tangent of 0 degree, 90 degrees, 400 degrees, negative 50 degrees, negative 12 degrees. So those angles not covered by right triangle approach, limited. Again, what are the angles here that can be considered only? Trigonometric functions of positive acute angle. So that is the limitation of right triangle approach. But it is actually realistic. Parang ito talaga yung triangle na what we call this, ito yung unang basis ng trigonometry, the original. They started here. But because of calculus, they need radian measure or the real number. That's why they came up with another what? Another approach. Another approach we have, so again here, gagamit tayo ng right triangle. Yan. You will have a right triangle. So this is, for instance, angle theta. And this is named as, this is, let's say, A, this is B, and this is angle C, angle B, and angle angle A or theta. So theta here is between what? Between 0 and 90 degrees. So positive acute pong. Okay? Yeah. Make use of that. The number 2 approach, number 2. Okay, number 2, we have Cartesian plane approach. Cartesian plane approach. Plane approach. Where a reference angle makes use of a reference angle, uses a reference angle, uses a reference angle, or reference triangle. Reference triangle to define drawn in what? Drawn in the Cartesian plane. Drawn in the Cartesian plane. Cartesian plane. Yeah. To define what? To define the 6 trigonometric functions. To define the 6 trigonometric functions. But this time, not limited to positive acute. Trigonometric. Yeah. And trigonometric functions, not just positive acute, but any angle. Yan, I will enclose functions of any angle, meaning general angle, any angle. Yan. Can be 0, 30, 100 degrees, 500 degrees, negative 45 degrees, negative 700 degrees, negative 540 degrees. So no limit. No? It's like unlimited. No? Unlimited. Eat all you can. Parang eat all you can. So right triangle approach is covered here in this Cartesian plane approach. Okay? So yan. It is included. It is actually, right triangle approach is actually the first quadrant case of what? Of the Cartesian plane approach. The right triangle in the Cartesian plane, first quadrant, that is the right triangle approach. Special case, it is covered there. Kaya even without discussing the right triangle approach, proceeding immediately to the Cartesian plane approach, it's all right. No? But there are people who can easily understand if they begin with the right triangle approach. No, without first looking at the negative, positive angle, and any angle in general. Just the positive acute angle. Cartesian plane approach. What time is it now? It's already time. Approach. Yan. Okay, so let's just finish these 3 approaches. And the next meeting, we're going to begin with the first approach. So here, we're going to make use of a Cartesian plane. Well, let's use ruler so that it will be nice. Yeah. So let's have a ruler here. So that's the Cartesian plane. Then we now have x-axis. So it makes use of Cartesian plane, of course. So you're going to draw the angle here with the vertex is at the one of the vertex of the triangle is at the origin. Yeah. So that's the Cartesian plane approach. So let's say this is y and this is my x. No? I'm going to draw a triangle. So this is my triangle here. This is the reference angle. So let's say this is my triangle. I mean my angle. It can be any angle. It can be any angle. So that's my angle. So my angle is more than 90 degrees. So that's my angle, guys. So rotation counterclockwise. So actually it is positive angle. So that's my theta. But I'm going to draw a reference angle. Draw a reference angle. It is where we are going to read the value of the functions of theta, trigonometric functions of theta from this right triangle here. So this is the reference angle. We call this angle, let's say alpha. Alpha is reference angle. Reference angle. And there are rules to follow so that you will have the correct sign for the trigonometric functions. So this is just guide. So, but what we are trying to define, the sixth trig of theta. Theta is any angle. Can be in the first quadrant, the angle. Can be the second, can be the third, fourth. So we call this Cartesian plane approach, children of the Philippines. The last approach, children of the Philippines, the circular function approach or unit circle approach. So the last one, guys. So this is the last approach. We're going to discuss them one by one. So we have number 3. What is number 3, guys? Unit circle approach. Unit circle approach. Ito yung tinatawag na circular approach, circular function approach. Yan, circular function. Circular function. So this time, we define trigonometric functions looking at length of an arc instead of an angle. We're going to define 6 trigonometric functions by what? By looking at the length of an arc, meaning we are dealing with real numbers, trigonometric functions of real numbers. This uses length of arcs, uses a length of an arc. This is a length of an arc, of an arc of a unit circle, kaya unit circle approach, unit circle, to define what? To define the 6 trigonometric functions, to define the 6, which is very useful in calculus. Actually, calculus is real number based 6 trigonometric functions. And it is where the second definition of trigonometry comes from. There is no triangle, so circular, the 6 trigonometric functions. But this time of what? Of real numbers, 6 trigonometric functions of real numbers. And these real numbers represent the length of an arc. Length of an arc. Okay. Now, what is nice is that there is one-to-one correspondence. If the length of an arc is, let's say, pi units, the measure of the central angle is pi radians, which is 180 degrees. So you can shift from circular to Cartesian plane, and special case, yung right triangle, if positive acute. Okay? So these are the 3 what? But of course, it makes use also of Cartesian plane, where you're going to draw the unit circle. Yeah. It's already time. So you will have a unit circle. Ayaw move. And you will draw unit circle. I hope I will able to draw a circle. Assume this is a circle. Yan, not nice. So we have this, no? And let's say we have a point on the unit circle, another point, so a point here, and another point here. Yan. So this is of length what? T units, for instance. T units. That's the value, for instance, of your S. No, length of your arc. S is T units. So this length, T units, numerically equal to this measure, to this angle. Yan. Yan. If this is T units, we call this T radians. T radians. So there is no problem actually. You can consider it as an angle. You can consider it as a length of an arc. Did you understand now, guys? Unit circle approach. So that's why trigonometric functions are sometimes called circular functions rather than trigonometric functions. If you derive the definitions from this unit circle, considering the argument in the function, not the angle, but the length of an arc, which is T units. So you can talk of sine T, cosine T, and so on. And you have a point somewhere here. This point is what we call, let's say, P, XY. Or sometimes dinedenote ng P theta. Yan. P theta. Okay? So if your theta is equal to T radians, well, theta here is equal to yan, T units. Yan. As a real number. Okay? Is that clear, children? Kaya may domain and range. Nanggaling dyan ang domain and range ng trigonometric functions from functions of real numbers. Trigonometric functions of real numbers. So, ang input mo, real numbers, ang output, real numbers din. Pero ang maganda, yung input mo na 2 units or 2, that is actually 2 radians for the central angle, 2 radians. And all you have to do is to convert to degrees to make it degree measure. So these are the 3 approaches that you can use or that you can have in trigonometry to define 6 trigonometric functions. Now, these three approaches you cannot find in the books in all the same time in the book. Books normally choose only 1 or 2, and most of them choose circular function because in preparation to calculus and together with the Cartesian plane approach. After all, right triangle approach is a special case. Number question, guys? So we're going to end here our discussion. Guys, we will be continuing next meeting.
Yes po.
Yes
Yes
po.
po.
Okay.